What if I told you that within the next century, humanity might not just visit Mars, but could potentially establish thriving cities across the solar system? The future of space travel isn't just about rockets and distant planets. It's about redefining what it means to be a species capable of exploring the stars. As we stand on the brink of technological breakthroughs that were once the stuff of science fiction, the question isn't if we'll venture further into the cosmos, but how far we'll go and what we'll discover along the way. From asteroid mining to interstellar probes, the next era of space exploration is poised to transform not just our understanding of the universe, but our very survival as a civilization. In this video, we're diving into 40 insane predictions for the future of space travel, each one more mind-bending than the last. Get ready to explore ideas that will challenge everything you thought was possible and discover why the stars might be closer than we ever imagined. The dream of venturing beyond our planet is no longer confined to astronauts and government space agencies. Over the past decade, private companies have taken center stage, transforming space travel from a distant aspiration into a tangible reality. Companies like SpaceX and Blue Origin aren't just pushing boundaries, they're rewriting the rules of what's possible. Their groundbreaking achievements, from reusable rockets to cost-effective launches, have opened the door to a new era of exploration. But this isn't just about sending satellites or probes into orbit. It's about making space accessible to everyone. Imagine waking up one morning in the not-too-distant future, say the 2030s, and deciding to spend your vacation floating above the Earth. Suborbital flights could become as routine as catching a plane across the country, offering a taste of weightlessness and a breathtaking view of our planet from the edge of space. Orbital hotels circling high above might provide luxurious accommodations where guests can gaze out at the curvature of the Earth while enjoying a gourmet meal. This isn't science fiction anymore. It's the direction we're heading in, thanks to the relentless innovation of these trailblazing companies. The economic ripple effects of this shift are enormous. Space tourism isn't just a niche industry. It's a catalyst for technological advancements that benefit countless other sectors. Think about the materials, energy systems, and life support technologies being developed to make these experiences possible. These innovations could revolutionize everything from transportation to healthcare, creating new jobs and industries along the way. The rise of commercial space travel isn't just about reaching the stars, it's about improving life here on Earth while inspiring us to think bigger. When we think about the moon, it's often seen as a distant, silent neighbor. But by the year 2040, it could become humanity's first off-world home. Lunar colonies are no longer the stuff of science fiction. They're a tangible goal within our reach. Picture this: self-sustaining habitats built using cutting-edge 3D printing technology, powered by solar energy, and designed to withstand the moon's harsh environment. These aren't just temporary shelters, they're the foundation for a permanent human presence beyond Earth. The key to making this vision a reality lies in resource extraction. The moon is rich in materials like water ice, which can be converted into drinking water, oxygen, and even rocket fuel. Imagine mining these resources to support not only the colonies but also future missions to Mars and beyond. It's like setting up a cosmic gas station where we can refuel and resupply without hauling everything from Earth. What makes these colonies so exciting is their potential as stepping stones. They're not just ends in themselves, they're launch pads for deeper space exploration. By mastering life on the moon, we'll gain the skills and technologies needed to tackle even greater challenges, like establishing a presence on Mars or venturing into the asteroid belt. It's a bold vision, but one that's within our grasp if we're willing to reach for it. Mars has long captured our imagination, but in the coming decades, it could become more than just a distant red dot in the night sky. It might become humanity's second home. By 2050, scientists and space agencies are aiming to establish permanent colonies on the Martian surface, turning science fiction into reality. But what does it take to make a planet with a thin atmosphere, freezing temperatures, and no breathable air habitable for humans? The challenges are immense, but so is the ingenuity driving these efforts. One of the biggest hurdles is radiation. Unlike Earth, Mars lacks a magnetosphere to shield its surface from harmful cosmic rays and solar radiation. Prolonged exposure could pose serious health risks, from increased cancer rates to damage to the nervous system. To combat this, researchers are exploring solutions like underground habitats lined with Martian soil or advanced shielding materials that could protect settlers from these invisible threats. Then there's the issue of low gravity. Mars has just 38% of Earth's gravity, which could lead to muscle atrophy, bone density loss, and other health problems over time. Scientists are already studying how astronauts adapt to microgravity on the International Space Station, but living on Mars would require even more innovative approaches. Artificial gravity systems, specialized exercise regimens, and even genetic modifications are all on the table as potential solutions. Resources are another critical concern. Mars is a barren landscape with no readily available water, food, or breathable air. To survive, colonists will need to rely on cutting-edge technologies to extract water from the soil, grow food in controlled environments, and produce oxygen from carbon dioxide. NASA's Perseverance rover has already demonstrated the ability to create oxygen from the Martian atmosphere, and experiments with hydroponic farming are showing promise for sustainable agriculture. Despite these challenges, the vision for Mars is not just about survival, it's about creating a thriving, self-sustaining society. Imagine cities where energy is harnessed from solar panels, where 3D printing technology builds homes from Martian materials, and where communities innovate to thrive in their new environment. This isn't just a distant dream, it's a goal within reach if we continue to push the boundaries of science and engineering. Mars could become the ultimate test of human resilience and creativity, a place where we learn to live not just on another planet but in harmony with it. Picture this, a network spanning not just continents but planets. In the not-too-distant future, high-speed internet could link Earth, the Moon, and Mars, revolutionizing how we communicate across the cosmos. This isn't science fiction, it's the next frontier in connectivity, and it's already in development through advanced laser communication systems. These systems, which use beams of light to transmit data, are far faster and more efficient than traditional radio waves, offering the potential for real-time communication across millions of miles. The implications are staggering. Imagine scientists on Earth collaborating seamlessly with astronauts on the Moon, or engineers guiding rovers on Mars without the frustrating delays we experience today. This interplanetary internet wouldn't just make exploration more efficient, it would open doors for unprecedented global cooperation. Researchers from different countries could work together on experiments in space, sharing data and insights as if they were in the same room. But it's not just about science. This network could also pave the way for new industries in space, from extraterrestrial tourism to off-world mining operations. Companies could manage their ventures remotely, relying on instant communication to make critical decisions. And for those of us still on Earth, it could mean live streaming footage from the surface of Mars, bringing the wonders of space closer than ever before. The development of interplanetary internet is still in its early stages, but the potential is undeniable. As we look to the stars, this technology could become the backbone of our extraterrestrial ambitions, connecting humanity in ways we've only dreamed of. The cosmos might be vast, but with high-speed internet spanning the solar system, it could feel a little smaller and a lot more connected. Picture a future where reaching space is as simple as stepping into an elevator and pressing a button. This isn't science fiction, it's the ambitious vision of space elevators, a concept that could transform how we access orbit. Imagine a colossal structure extending from Earth's surface into space, tethered by a cable strong enough to carry cargo and passengers into the cosmos. The idea has been around for decades, but recent advancements in materials science and engineering are bringing it closer to reality. At the heart of this concept lies the need for an incredibly strong yet lightweight material. Traditional steel cables would snap under their own weight, but breakthroughs in carbon nanotechnology have introduced materials like graphene and carbon nanotubes. These are not only stronger than steel, but also light enough to make the idea feasible. The challenge: producing these materials at the scale required for a space elevator, which could stretch over 62,000 miles into space. But it's not just about the cable. The entire structure would require precise engineering to withstand forces like wind, gravity, and orbital mechanics. Anchored to a floating platform in the ocean, the elevator would need to balance the tension between Earth's rotation and the counterweight in space. The logistics are mind-bending, but the payoff could be enormous. By eliminating the need for rocket fuel and reusable spacecraft, space elevators could slash the cost of reaching orbit by over 90%, opening up endless possibilities for exploration and industry. Of course, there are hurdles to overcome, from the risk of space debris to the challenges of maintaining such a massive structure. The path to a functional space elevator is fraught with complexity. Yet, with each passing year, researchers are making strides in materials, robotics, and space infrastructure that bring us closer to this futuristic vision. The dream of a space elevator isn't just about convenience, it's about redefining humanity's relationship with the cosmos, making space accessible in a way that was once unimaginable. Picture this: floating in the vast emptiness of space are treasure chests packed with rare metals and minerals, just waiting to be unlocked. These aren't mythical chests, they're asteroids, remnants of the early solar system, rich with resources like platinum, gold, and even water. What if these space rocks could become the key to solving Earth's resource shortages? That's the promise of asteroid mining, a concept that's quickly shifting from science fiction to a tangible future industry. To tap into these cosmic riches, we'll need some cutting-edge technology. Prospecting missions would begin with advanced telescopes and spacecraft capable of identifying and reaching these distant objects. Once there, robotic miners equipped with drills and extraction systems would go to work, harvesting materials directly from the asteroid's surface or even breaking it down entirely. Water, a potential byproduct of some asteroids, could be converted into rocket fuel, enabling longer missions and reducing the need for resupply from Earth. The economic potential here is staggering. A single asteroid could contain billions of dollars worth of precious metals, enough to disrupt global markets and fund further space exploration. Beyond the financial gains, asteroid mining could also reduce the environmental toll of traditional mining on Earth. Instead of tearing through forests and polluting rivers, we could source these materials from the void of space, leaving our planet's ecosystems untouched. Of course, this isn't without its challenges. The cost of developing and launching these mining systems is astronomical, and questions about ownership and regulation remain unresolved. Who gets to claim these space treasures? How do we ensure fair access for all nations? These are hurdles that will need to be addressed as we move closer to making asteroid mining a reality. But one thing's certain: the next gold rush may not be on Earth. It could be out there among the stars. What if we could travel faster than light, bending the very fabric of space-time to reach distant stars in days instead of millennia? This isn't just science fiction, it's the promise of warp drives, a concept rooted in theoretical physics that could revolutionize space travel. At its core, a warp drive doesn't propel a spacecraft through space at incredible speeds. Instead, it manipulates space-time itself, compressing it in front of the ship and expanding it behind, effectively creating a warp bubble that allows the craft to ride this distortion faster than light would travel in normal space. The idea was popularized by physicist Miguel Alcubierre in the 1990s, who proposed a mathematical model for such a drive based on Einstein's theory of general relativity. While it sounds like something straight out of Star Trek, the math checks out, at least in theory. Recent advancements have brought this concept closer to reality. Researchers are exploring ways to generate the enormous amounts of energy required and stabilize the warp bubble, with some even suggesting that exotic matter with negative energy density might be the key. But the challenges are staggering. Creating and sustaining a warp bubble demands energy levels that currently surpass anything humanity can produce. There's also the issue of radiation exposure and the potential for catastrophic spacetime disruptions. And yet, the dream persists. Institutions like NASA Advanced Propulsion Physics Laboratory, known as EagleWorks, are actively investigating these possibilities, pushing the boundaries of what we know about physics and engineering. So, could warp drives become a reality? The answer lies in our ability to bridge the gap between theory and practice. While the obstacles are immense, the potential rewards traveling to distant galaxies in a lifetime make this one of the most exciting frontiers in space exploration. The journey to faster-than-light travel might be long, but every step brings us closer to a future where the stars are no longer out of reach. Picture a world where the red, dusty plains of Mars could one day be transformed into lush, green landscapes teeming with life. This isn't just the stuff of science fiction, it's a concept scientists are actively exploring, known as terraforming. The idea is to take a barren, lifeless planet and engineer it into a haven for humans, plants, and animals. But how could such a monumental task even be possible, and what would it take to make it a reality? At its core, terraforming involves altering a planet's atmosphere, temperature, and surface conditions to mimic Earth. For Mars, this might start with releasing greenhouse gases to thicken its atmosphere and trap heat, gradually warming the planet. Over time, this could lead to liquid water forming on the surface, a crucial step for sustaining life. Technologies like giant mirrors in space could redirect sunlight to melt polar ice, and genetically engineered microbes might be introduced to produce oxygen. It's a process that could take centuries, but the potential rewards are staggering: a second home for humanity. Of course, transforming a dead world into a thriving one isn't just a technical challenge, it's also an ethical one. Would we have the right to alter an entire planet's ecosystem, even if it currently supports no life? What if microbial life already exists there, hidden beneath the surface? These questions force us to consider the responsibility that comes with such power. Terraforming isn't just about survival, it's about stewardship, ensuring that we don't repeat the mistakes we've made on Earth. The technologies required for terraforming are still in their infancy, but they're evolving rapidly. Advances in genetic engineering, climate modeling, and space infrastructure are bringing us closer to making this vision a reality. And while the challenges are immense, the potential to create a second Earth, a backup plan for humanity, is too compelling to ignore. Terraforming isn't just about science, it's about hope, ambition, and the enduring human drive to explore and thrive in the cosmos. Imagine floating weightlessly through a spacecraft, drifting effortlessly from one corner to another. While it might sound like a dream, prolonged exposure to zero gravity poses serious challenges to the human body: muscle atrophy, bone density loss, and even changes in vision. So, how do we make space feel more like home for astronauts on long missions? The answer lies in artificial gravity, a concept that could revolutionize space travel as we know it. Artificial gravity isn't just about comfort, it's a necessity for long-term human survival in space. One of the most promising methods to create it involves centrifugal force. Picture a rotating spacecraft or space station. As it spins, the outward force pushes objects toward the walls, mimicking the sensation of gravity. It's like when you're on a merry-go-round and feel yourself being pulled outward, except in this case, that pull could keep astronauts grounded, literally and figuratively. But it's not just about spinning in circles. The design of these rotating structures would need to be carefully calibrated. Too fast, and astronauts might experience dizziness or nausea. Too slow, and the effect would be minimal. Studies suggest a rotation rate of about 2 to 4 revolutions per minute, coupled with a radius of at least 100 to 200 meters, could create a comfortable and effective gravity-like environment. This would allow astronauts to walk, eat, and sleep as they would on Earth, reducing the physical toll of zero gravity. Another approach being explored is linear acceleration. Think of it like an elevator that's constantly moving upward. If a spacecraft accelerated at the same rate as Earth's gravity, 9.8 meters per second squared, it could create a similar gravitational pull. While this method is more energy-intensive, it could be particularly useful for shorter journeys or specific phases of a mission. Artificial gravity isn't just a sci-fi fantasy. It's a practical solution to one of the biggest hurdles in space exploration. As we look toward missions to Mars and beyond, creating environments that support human health and well-being will be critical. By turning the dream of artificial gravity into reality, we're not just making space travel possible, we're making it sustainable for future generations of explorers. Imagine a world where our energy needs are met not by fossil fuels but by the limitless power of the sun, harvested not on Earth but in space. This is the promise of space-based solar power, a concept that could revolutionize how we generate and distribute energy. Massive solar arrays orbiting high above our planet would capture sunlight 24 hours a day, unaffected by weather or the cycle of day and night. This energy could then be beamed back to Earth using microwaves or lasers, providing a constant, reliable source of power. The efficiency of space-based solar power is staggering. In space, solar panels can operate at peak capacity without the interference of Earth's atmosphere, which scatters and absorbs sunlight. This means they could generate up to 10 times more energy than equivalent panels on the ground. And unlike traditional solar farms, space-based systems wouldn't compete for valuable land or disrupt ecosystems, making them an environmentally friendly alternative. But the benefits don't stop there. By tapping into this virtually inexhaustible energy source, we could drastically reduce greenhouse gas emissions, helping to combat climate change. It could also provide energy to remote or disaster-stricken areas where traditional infrastructure might be damaged or non-existent. While the technology is still in its early stages, the potential is enormous. Projects like NASA's Space Solar Power Initiative and private ventures are already exploring how to make this vision a reality. Of course, challenges remain. Building and launching these massive structures into orbit would require significant advancements in materials and spaceflight technology, and ensuring the safe transmission of energy back to Earth is no small feat. Yet, with the rapid pace of innovation, these hurdles may soon be overcome. Space-based solar power isn't just a dream, it's a glimpse into a future where energy is clean, abundant, and sourced from the stars. What if the future of space travel didn't involve rockets at all? Picture a sleek, aircraft-like vehicle that can take off from a runway, soar into the upper atmosphere at unimaginable speeds, and glide seamlessly into orbit. This isn't science fiction, it's the promise of hypersonic spaceplanes. These next-generation vehicles are being designed to travel at speeds exceeding 5 times the speed of sound, revolutionizing how we think about reaching space. Hypersonic spaceplanes aim to bridge the gap between traditional aircraft and spacecraft, combining the best of both worlds. Unlike conventional rockets that require massive amounts of fuel and complex infrastructure, spaceplanes could be reusable, more cost-effective, and far more efficient. Imagine boarding a vehicle that feels more like a high-speed jet than a space capsule. Within minutes, you're cruising at hypersonic speeds, breaking through the atmosphere and into the vastness of space. One of the most exciting aspects of hypersonic spaceplanes is their potential to drastically reduce travel time. For example, reaching low Earth orbit could take just a fraction of the time it currently does with traditional rockets. And when it comes to interplanetary travel, these vehicles could serve as the first leg of the journey, shuttling passengers and cargo to larger spacecraft awaiting in orbit. This could make missions to Mars or even the outer planets more feasible and efficient. Companies and agencies around the world are already investing in this technology. From experimental prototypes to advanced computational models, the race to develop a functional hypersonic spaceplane is well underway. While challenges like heat resistance and propulsion systems still need to be overcome, the progress being made is nothing short of remarkable. The implications of hypersonic spaceplanes go beyond just speed and efficiency. They could democratize access to space, making it more accessible for research, tourism, and even commercial ventures. The dream of hopping on a flight to another continent or another planet could soon become a reality. This leap in technology isn't just about getting to space faster, it's about redefining how we explore and utilize it. Hypersonic spaceplanes could be the key to unlocking a new era of space travel, one that's faster, safer, and more sustainable. The search for extraterrestrial life has captivated humanity for centuries, but today we're closer than ever to finding answers. Cutting-edge missions and technologies are pushing the boundaries of what's possible, turning science fiction into science reality. Take NASA's Perseverance rover, for example. It's not just exploring Mars, it's actively searching for signs of ancient microbial life. By analyzing rock samples and searching for biosignatures, Perseverance could provide the first concrete evidence that life once existed on the red planet. But Mars isn't the only focus. Telescopes like the James Webb Space Telescope are scanning distant exoplanets for biosignatures indicators like oxygen, methane, or water vapor that could hint at the presence of life. These telescopes are peering into the atmospheres of worlds light years away, searching for clues that might rewrite our understanding of life in the universe. And it's not just about finding life as we know it. Missions like Europa Clipper aim to explore Jupiter's moon Europa, which harbors a vast subsurface ocean. This icy moon could be home to extremophiles organisms that thrive in the harshest conditions. If life exists there, it could redefine where we think life can survive. The hunt for extraterrestrial life is more than a scientific endeavor. It's a quest to answer one of humanity's most profound questions: are we alone in the universe? With every new mission and discovery, we're inching closer to finding out. And who knows, the answer might be just one rover scan or telescope observation away. Picture a civilization so advanced that it doesn't just tap into the energy of planets, but an entire star. That's the idea behind the Dyson Sphere, a megastructure so massive it could completely encircle a star, capturing its energy and transforming it into an almost limitless power source. First proposed by physicist Freeman Dyson in the 1960s, this concept pushes the boundaries of what we think is possible in energy harvesting. A Dyson sphere isn't just a single solid shell, it's more likely a swarm of orbiting structures, like solar panels on an unimaginable scale, working together to harness every bit of a star's output. The potential here is staggering. A single star emits more energy in 1 second than humanity has consumed in its entire history. By capturing even a fraction of that energy, a Dyson Sphere could power technologies far beyond our current imagination. Things like interstellar travel, megacities spanning entire solar systems, or even the creation of artificial worlds. It's not just about energy, it's about unlocking the next stage of cosmic evolution for a civilization. But building something like this is no small task. The materials alone would require mining entire planets or even asteroids, not to mention the engineering challenges of constructing something on this scale. And yet, the concept has inspired scientists and futurists alike, not just as a blueprint for the future, but as a tool for thinking about what might be possible. Interestingly, the search for Dyson spheres isn't just theoretical. Astronomers have begun scanning the cosmos for signs of these megastructures, looking for unusual patterns of heat or light that might indicate a star's energy is being harnessed. While we haven't found one yet, the idea itself serves as a fascinating reminder of how far we've come and how much further we might go. After all, if a civilization can harness the power of a star, what can't it achieve? Now, let's shift our focus to a concept that sounds like science fiction but is increasingly becoming science fact: quantum communication. Picture this: traveling to the stars would mean staying connected across unimaginable distances, and traditional methods of communication simply wouldn't cut it. Enter quantum entanglement, a phenomenon so strange even Einstein called it spooky action at a distance. At its core, quantum entanglement allows particles to be connected in such a way that the state of one instantly influences the state of another, no matter how far apart they are. This could be the key to unlocking instantaneous communication across the cosmos. Imagine sending a message to a spacecraft light years away, and it arrives instantly without any delay. That's the potential of quantum communication. Unlike radio waves or lasers, which are limited by the speed of light, quantum entanglement doesn't seem to care about distance. This could revolutionize how we stay in touch with astronauts, probes, and even future colonies on distant planets. But here's the kicker: quantum communication isn't just fast, it's also incredibly secure. Because of the unique properties of entangled particles, any attempt to intercept or tamper with the message would immediately disrupt the connection, alerting both parties to the breach. In a future where space travel becomes more common, this level of security could be essential for protecting sensitive data and ensuring safe, reliable communication. Of course, this technology is still in its early stages. Scientists are working hard to overcome challenges like maintaining entanglement over long distances and building the infrastructure needed to support quantum networks. But if we can crack the code, the implications for space exploration are staggering. Think about it: a galaxy-wide internet where information travels faster than light and communication is as seamless as a conversation across the room. So, while quantum communication might sound like the stuff of dreams, it's a field brimming with possibility, one that could redefine how we connect across the stars. As we continue to explore the cosmos, there's an invisible challenge orbiting right above us: space debris. Picture this: thousands of defunct satellites, discarded rocket stages, and even fragments from collisions, all whirling around Earth at staggering speeds. This isn't just a cluttered mess, it's a serious threat to active satellites, the International Space Station, and future space missions. Collisions with even the smallest piece of debris can cause catastrophic damage, creating a chain reaction known as the Kessler syndrome, where one collision leads to many more, potentially making space inaccessible. But here's the good news: scientists and engineers are already tackling this problem with creativity and ingenuity. One of the most promising solutions involves space janitors, specialized satellites designed to capture and remove debris. These robotic cleaners use technologies like nets, harpoons, and even robotic arms to grab and safely deorbit junk, burning it up in Earth's atmosphere. Another approach uses lasers to nudge debris out of orbit, reducing the risk of collisions without physical contact. Companies like Astroscale and ClearSpace are leading the charge, developing missions to prove that cleaning up space isn't just possible, it's essential. The stakes are high, but so is the potential for innovation. Imagine a future where space is as clean and navigable as our oceans, where satellites and spacecraft can operate safely without dodging floating hazards. It's not just about preserving our current capabilities. It's about ensuring that future generations can continue to explore, communicate, and thrive in the final frontier. And while the challenge is immense, the solutions being developed today are paving the way for a cleaner, safer orbit tomorrow. What if you could walk on the surface of Mars or float through the rings of Saturn without ever leaving your living room? Virtual reality is poised to revolutionize how we experience space exploration, making it accessible to anyone with a VR headset. This isn't just about entertainment, it's a groundbreaking tool for education and public engagement. Imagine students taking virtual field trips to the International Space Station, or families exploring distant galaxies together in vivid detail. VR allows us to bring the cosmos to life in ways that were once the stuff of science fiction. By simulating real missions or recreating celestial wonders, this technology can inspire a new generation of explorers and make the vastness of space feel tangible. It's not just about seeing space, it's about feeling like you're truly there, opening doors to understanding and curiosity that textbooks or videos simply can't match. And as VR tech continues to evolve, the line between reality and virtual exploration will blur even further, making the universe a place we can all visit, no rocket required. What if we could send robots into space that not only build structures but also copy themselves to expand their workforce? This isn't science fiction. It's a concept called self-replicating robots, and it could revolutionize how we approach space exploration. Picture this: a single robot lands on the Moon or Mars, equipped with the ability to gather raw materials and assemble new versions of itself. Over time, a small team of robots could grow into an entire colony, constructing habitats, mining resources, and preparing the way for human settlers, all without constant oversight from Earth. The beauty of this idea lies in its efficiency. Instead of launching heavy, expensive equipment or sending astronauts to perform risky construction tasks, we could rely on these robots to do the heavy lifting literally. By using materials found on site, like lunar regolith or Martian soil, they could minimize the need for supplies from Earth, drastically cutting costs and reducing our dependence on costly resupply missions. But how would these robots actually work? Imagine a machine with advanced 3D printing capabilities, combined with artificial intelligence to guide its decisions. It could extract metals, fabricate parts, and assemble new robots piece by piece. Some designs even suggest that these robots could repair themselves or adapt to new tasks as needed, making them incredibly versatile for long-term missions. Of course, there are challenges to overcome. We'd need to ensure these robots can operate reliably in harsh environments with limited human oversight. There's also the question of how to program them to avoid unintended consequences, like overusing resources or creating structures that aren't safe. But if we can tackle these hurdles, self-replicating robots could become the backbone of our off-world ambitions, turning barren landscapes into thriving outposts for humanity's future. Picture a spacecraft no larger than a shoebox, hurtling through the void of space at speeds that defy comprehension. This isn't science fiction, it's the ambitious vision behind interstellar probes, humanity's first emissaries to the stars. These probes are designed to travel to nearby star systems, carrying with them the hopes of unlocking the secrets of the cosmos. But the journey is anything but simple. Even the closest stars are unimaginably far away, with Proxima Centauri, our nearest neighbor, sitting at a staggering 4.24 light-years from Earth. To put that into perspective, if we launched a probe today using current technology, it would take tens of thousands of years just to reach it. The challenges of such a mission are immense, starting with propulsion. Traditional chemical rockets, the workhorses of space exploration, simply aren't up to the task. Instead, scientists are exploring cutting-edge technologies like light sails, which harness the power of lasers to propel probes to a fraction of the speed of light. Then there's the issue of communication. Over such vast distances, even signals traveling at the speed of light would take years to reach Earth, making real-time control impossible. These probes would need to operate autonomously, relying on advanced artificial intelligence to navigate, collect data, and make decisions on their own. And let's not forget the harshness of space itself. Galactic cosmic rays, micrometeoroids, and the extreme cold of interstellar space pose significant risks to the delicate instruments on board. Shielding and redundancy would be critical to ensure these probes survive their epic journey. Despite these hurdles, the potential rewards are unparalleled. Imagine receiving data from a star system light years away, images of alien worlds, chemical analyses of distant atmospheres, and perhaps even evidence of extraterrestrial life. Interstellar probes represent humanity's first steps into the wider galaxy, a testament to our curiosity and ingenuity. While the challenges are daunting, they're not insurmountable. With each technological breakthrough, we move closer to turning this dream into reality, one star at a time. Imagine being able to slip into a deep, dreamless sleep and wake up light years away, perfectly preserved as if no time had passed at all. Cryonics, the practice of freezing the human body at ultra-low temperatures, isn't just a sci-fi fantasy. It's being seriously considered as a game-changer for space travel. The idea is simple yet profound. By placing astronauts into a state of suspended animation, we could dramatically reduce the physical and psychological challenges of long-duration missions. Instead of spending decades awake in confined spacecraft, travelers could skip the journey entirely, arriving at their destination ready to explore. One of the biggest hurdles in space exploration is the sheer amount of time it takes to reach distant worlds. Even with advanced propulsion systems, trips to planets outside our solar system could take centuries. Cryonics offers a potential solution by slowing down the body's metabolic processes to near zero, effectively pausing aging and biological functions. This technology isn't just about convenience, it's about survival. Radiation exposure, muscle atrophy, and the mental strain of isolation are all significant risks for astronauts on lengthy missions. By entering a frozen state, these dangers could be minimized, if not entirely avoided. But how does it work? The process involves cooling the body to around -196 degrees Celsius, using a combination of cryoprotectants to prevent ice crystals from forming and damaging cells. While cryonics is still in its experimental stages, recent advancements in medical science and nanotechnology are bringing this concept closer to reality. Researchers are exploring ways to safely thaw and revive cryogenically frozen organisms, with some promising results in small-scale experiments. Of course, there are challenges to overcome. Ensuring that the brain and vital organs remain intact during freezing and thawing is a monumental task. Ethical concerns also come into play, as the technology raises questions about consent, identity, and the potential risks of revival. Still, the potential rewards are immense. Cryonics could open the door to interstellar travel, allowing humanity to reach distant stars without the limitations of our biological clocks. As we continue to push the boundaries of what's possible, cryonics represents a fascinating intersection of biology, technology, and the human spirit of exploration. It's not just a tool for space travel, it's a testament to our relentless drive to overcome the limits of our existence and venture into the unknown. The concept of a space economy might sound like science fiction, but it's rapidly becoming a tangible reality. Imagine a future where entire industries thrive beyond Earth, generating trillions of dollars in value. Space mining, for instance, could tap into the vast reserves of rare metals and minerals found on asteroids, transforming how we think about resource scarcity. These celestial bodies are rich in platinum, gold, and other materials that are becoming increasingly hard to find on our own planet. By harnessing these extraterrestrial resources, we could revolutionize industries like electronics, energy, and manufacturing. But it's not just about mining. Space could also become a hub for advanced manufacturing. In the microgravity environment of space, scientists can create materials and products that are impossible to produce on Earth. Think about ultra-pure crystals for semiconductors or perfectly spherical ball bearings that could make machinery more efficient. The potential for innovation is staggering, and companies are already investing heavily in research and development to make these ideas a reality. Then there's the burgeoning space tourism industry. While currently reserved for the ultra-wealthy, the cost of space travel is expected to drop dramatically as technology advances. This could open the door for more people to experience the wonders of space, creating a new sector of adventure travel. Hotels in orbit, lunar vacation packages, and even trips to Mars could become part of the global tourism market. And let's not forget satellite services, which are already a cornerstone of the space economy. From global internet coverage to advanced weather monitoring, satellites play a critical role in our daily lives. As demand for these services grows, so too will the need for more sophisticated and efficient satellite networks. Companies are exploring reusable rockets and modular satellite designs to reduce costs and increase accessibility. The space economy isn't just about profit, it's about pushing the boundaries of human potential. It's about solving problems on Earth by looking beyond it. As we continue to explore and innovate, the possibilities are as limitless as the universe itself. As we venture further into the cosmos, a fascinating new discipline is taking shape, one that blends the mysteries of the past with the boundless possibilities of the future. Space archaeology is not about digging in the dirt, it's about uncovering the cosmic history hidden among the stars. Picture this: ancient artifacts drifting through the void, remnants of civilizations that once thrived on distant worlds or perhaps even in our own solar system. This emerging field aims to piece together the stories of those who may have come before us, offering a glimpse into the universe's untold chapters. Space archaeologists aren't just looking for alien relics, though that's certainly part of the allure. They're also examining the traces of human activity in space, from abandoned satellites to the Apollo landing sites. These sites are like time capsules frozen in the vacuum of space, preserving the early days of human exploration for future generations to study. Imagine the insights we could gain by analyzing the technology, tools, and even the footprints left behind by the pioneers of space travel. It's a way to honor our own history while searching for the echoes of others. But the real intrigue lies in the search for extraterrestrial artifacts. Could there be evidence of advanced civilizations buried beneath the surface of Mars or hidden in the icy moons of Jupiter and Saturn? Space archaeologists use cutting-edge technology like high-resolution imaging, spectroscopy, and AI-powered analysis to scan celestial bodies for anomalies that might hint at intelligent design. The discovery of even a single artifact could revolutionize our understanding of the universe and our place within it. It's a quest that bridges science and imagination, inviting us to wonder what secrets the cosmos might be holding. This field isn't just about discovery, it's about connection. By studying the remnants of other civilizations, we're reminded that we're part of something much larger than ourselves. Whether we're examining the ruins of an alien city or preserving the first steps of human exploration, space archaeology invites us to reflect on the legacy we're leaving behind. What will future civilizations think when they uncover our artifacts among the stars? It's a question that challenges us to think beyond our own time and consider the enduring impact of our journey into the unknown. As we continue to push the boundaries of space exploration, we're faced with a question that's as profound as it is complex. What are the ethics of colonizing other worlds? It's not just about whether we can do it, but whether we should. Imagine a scenario where humanity discovers a planet rich in resources, minerals, water, or even energy sources. The immediate instinct might be to harvest these for Earth's benefit, but who decides what's fair? Is it ethical to exploit resources from another planet when we're still grappling with how to manage our own? Then there's the possibility of encountering extraterrestrial life, no matter how small or primitive. What rights would these life forms have? If we colonize a planet that's already home to microbes or other organisms, do we have a moral obligation to preserve their environment? These aren't just hypotheticals, they're questions we'll need to answer before we take our first steps toward permanent settlements beyond Earth. And let's not forget the ethical implications for humanity itself. Space colonization could offer a fresh start, but it also raises concerns about inequality. Who gets to go? Will it be the wealthiest and most powerful, leaving others behind? Or will we prioritize fairness and accessibility, ensuring that space becomes a shared frontier for all? These dilemmas remind us that space exploration isn't just a scientific endeavor, it's a deeply human one. It forces us to confront our values, our responsibilities, and our place in the universe. As we dream of building cities on Mars or mining asteroids, we must also ask ourselves, what kind of future do we want to create, and what are we willing to sacrifice to get there? As humanity sets its sights on long-term missions and eventual colonies beyond Earth, one critical challenge emerges. How do we grow food in the harsh environment of space? Space-based agriculture isn't just a futuristic concept, it's a necessity for survival. In zero gravity, traditional farming methods fall short, but scientists and engineers are already pioneering innovative solutions to grow plants in orbit and beyond. Picture this, a spacecraft or lunar habitat filled with lush, green vegetation, providing fresh produce for astronauts while recycling carbon dioxide into oxygen. This isn't science fiction, it's the reality being tested in experiments aboard the International Space Station. Plants like lettuce, radishes, and wheat have been successfully cultivated in microgravity, proving that farming in space is possible. But growing plants in zero gravity comes with unique hurdles. Without gravity, water doesn't flow downward and roots struggle to anchor themselves. To solve these problems, scientists have developed hydroponic and aeroponic systems where plants grow in nutrient-rich water or mist instead of soil. These methods not only conserve precious resources but also allow crops to thrive in confined spaces. Light is another critical factor. In the absence of natural sunlight, LED grow lights are used to provide the specific wavelengths plants need for photosynthesis. These lights can be fine-tuned to optimize growth, ensuring that crops mature efficiently even in the depths of space. Beyond sustaining astronauts, space-based agriculture could play a vital role in future colonies on the Moon or Mars. Imagine greenhouses dotting the Martian landscape, producing food for settlers while contributing to a self-sustaining ecosystem. These advancements could reduce reliance on Earth for resupply missions, making long-term habitation in space more feasible. The implications of space farming extend far beyond survival. It's about creating a sense of normalcy and connection to Earth for those living far from home. Fresh produce not only provides essential nutrients but also boosts morale, offering a taste of the familiar in an otherwise alien environment. As we continue to push the boundaries of space exploration, the ability to grow food in zero gravity will be a cornerstone of our journey. It's a testament to human ingenuity and adaptability, proving that even in the most challenging conditions, we can cultivate life and sustain our dreams of exploring the cosmos. Artificial intelligence is rapidly becoming the backbone of space exploration, revolutionizing how we analyze data, navigate the cosmos, and support human missions. One of its most transformative roles lies in processing the staggering amounts of information gathered by telescopes, rovers, and satellites. Think about the James Webb Space Telescope, capturing images so vast and detailed that it would take humans years to sift through. AI algorithms, however, can analyze this data in seconds, identifying patterns, anomalies, and potential discoveries that might otherwise go unnoticed. It's like having a tireless cosmic detective working around the clock to uncover the universe's secrets, but AI's capabilities extend far beyond data analysis. It's also taking the helm in piloting spacecraft, especially in situations where human intervention isn't feasible. For instance, missions to distant planets or asteroids often face communication delays due to the vast distances involved. AI-powered systems can make real-time decisions, adjusting trajectories, avoiding hazards, and ensuring the mission stays on course. This level of autonomy is crucial for exploring uncharted territories, where split-second decisions can mean the difference between success and failure. And let's not forget the role of AI in supporting astronauts during their missions. From managing life support systems to assisting with complex repairs, AI acts as a reliable co-pilot in the harsh environment of space. Advanced AI companions can even provide emotional support, helping astronauts cope with the isolation and stress of long-duration missions. Imagine a future where AI not only keeps spacecraft running smoothly, but also ensures the well-being of the humans on board, creating a seamless partnership between technology and humanity. This integration of AI into space exploration isn't just about efficiency, it's about pushing the boundaries of what's possible. By handling the heavy lifting of data and navigation, AI allows scientists and engineers to focus on the bigger picture, understanding the universe and our place within it. As we continue to explore the final frontier, artificial intelligence will undoubtedly be at the forefront, guiding us every step of the way. As we venture further into the realm of space exploration, a fascinating question emerges. Could space tourism evolve from a luxury for the elite to a necessity for humanity? Right now, it's easy to dismiss it as a high-priced adventure reserved for the wealthy, but let's consider the bigger picture. What if this isn't just about joyrides beyond Earth's atmosphere, but a stepping stone towards something far more profound? Think about how air travel transformed over the last century. What was once an exclusive experience is now a routine part of life, connecting people, cultures, and economies across the globe. Space tourism could follow a similar trajectory, becoming not just a novelty but a catalyst for global collaboration and innovation. Imagine a future where spaceports are as common as airports, where ordinary people can experience the awe of looking back at our planet from above. This shift could reshape our perspective, fostering a sense of unity and shared responsibility for Earth's future. But the societal impact goes beyond just accessibility. Making space travel a reality for more people could ignite a new wave of curiosity and ambition. Students who once dreamed of becoming astronauts might now see themselves as space engineers, researchers, or even entrepreneurs in a thriving space economy. The ripple effect could inspire generations to tackle challenges we haven't even imagined yet. Of course, there are challenges to address. the cost, environmental impact, and ethical considerations of space tourism must be carefully weighed. But if we approach this with foresight and responsibility, the benefits could outweigh the risks. After all, history has shown us that progress often begins with bold, seemingly impossible ideas. Space tourism might just be the spark that propels humanity into a new era of exploration and discovery. And let's not forget the cultural shift it could bring. Experiencing space firsthand has a unique way of altering one's worldview, something astronauts often describe as the overview effect. If more people have the chance to witness Earth from orbit, it could deepen our collective appreciation for our fragile planet and our shared humanity. What starts as a luxury could become a necessity, not just for individuals, but for the future of our species. The silence of the cosmos is one of the most profound mysteries we face as a species. With billions of galaxies, each containing billions of stars and planets, the universe seems almost designed to harbor life. Yet, despite our best efforts, we've found no concrete evidence of intelligent civilizations beyond Earth. This is the heart of the Fermi Paradox. If the universe is so vast and ancient, where is everyone? One possibility is that advanced civilizations are incredibly rare, perhaps emerging only under the most extraordinary conditions. Life might be abundant, but intelligent life capable of interstellar communication or travel could be a cosmic fluke. Another theory suggests that civilizations may rise and fall quickly, leaving behind only brief traces of their existence. If a society reaches a certain technological level but fails to manage its resources or avoid self-destruction, it might vanish before ever making contact with others. Some scientists propose that we're simply looking in the wrong places or using the wrong methods. Our current technologies have limitations, and the vastness of space means that signals or signs of life could be easily missed. Others argue that advanced civilizations might be deliberately avoiding us, either because they've determined we're not ready for contact or because they're following some form of universal protocol we don't yet understand. The implications for space exploration are immense. If intelligent life is out there, the search for it could redefine our place in the universe and inspire humanity to reach even greater technological heights. On the other hand, if we are truly alone, it could highlight the fragility and uniqueness of life, urging us to protect our planet and expand our presence beyond it. This paradox isn't just a scientific question, it's a philosophical one. It challenges us to think deeply about our origins, our future, and the nature of existence itself. As we continue to explore the cosmos, the search for answers to the Fermi Paradox will remain one of the most compelling and humbling endeavors of our time. What if the vastness of space wasn't a barrier to communication but a bridge? In this future, humanity and alien civilizations could connect through something far more extraordinary than our current internet, a cosmic internet, spanning galaxies and enabling the exchange of knowledge on an unimaginable scale. Picture this, a network of advanced relay stations powered by quantum entanglement or gravitational wave technology, transmitting data faster than the speed of light. This wouldn't just be about sharing cat videos or social media posts, it would be a unified platform for sharing scientific breakthroughs, cultural histories, and even artistic expressions across the stars. The implications of such a system are staggering. For one, it could accelerate the pace of discovery exponentially. Imagine a civilization in Andromeda sharing their understanding of dark energy, or a society in the Milky Way contributing insights into terraforming barren planets. This cosmic internet could essentially function as a galaxy-wide library, where every participant adds to the collective knowledge of the universe. But it's not just about science. Art, music, and philosophy could also flow freely, enriching cultures and fostering a deeper sense of unity among disparate civilizations. Of course, building such a network wouldn't be easy. The challenges are immense, ranging from technological hurdles like maintaining stable communication over billions of light years to ethical questions about how to ensure fair and respectful exchange. Who would govern this galactic network? How would we protect it from misuse or interference? These are questions humanity would need to grapple with as we take our first steps toward becoming a truly interstellar species. Yet the potential rewards make it a vision worth pursuing. A cosmic internet could transform not just how we communicate, but how we think about our place in the universe. It would remind us that we're part of something much larger, an interconnected web of life, curiosity, and creativity stretching across the cosmos. Space weather might sound like something out of a sci-fi movie, but it's a very real and significant challenge for space travel. Imagine the Sun, our nearest star, occasionally unleashing bursts of energy in the form of solar flares or coronal mass ejections. These events send waves of charged particles and radiation hurtling through space, creating what we call cosmic storms. For astronauts and spacecraft, these storms pose serious risks, everything from disrupting electronics to exposing crew members to dangerous levels of radiation. So, how do we navigate these invisible threats? One key solution lies in advanced shielding technologies. Spacecraft are being designed with materials that can block or absorb harmful radiation, acting like a protective barrier against the sun's outbursts. Think of it as a cosmic umbrella shielding those inside from the storm. But it's not just about the hardware. Scientists are also developing early warning systems. By monitoring the sun's activity, we can predict when a solar flare or radiation surge might occur, giving astronauts time to take shelter in specially reinforced areas of the spacecraft. But here's where it gets even more fascinating. Nature itself might offer solutions. Scientists are exploring how natural shielding, like lunar or Martian caves, could provide safe havens for astronauts during long missions. These underground spaces could act as a buffer against radiation, blending ancient geology with cutting-edge space technology. The challenge is immense, but the ingenuity of humanity is rising to meet it, ensuring that our journey into the cosmos is as safe as it is awe-inspiring. As we venture further into the cosmos, the tools we use to observe it are evolving at an incredible pace. Today's telescopes are already marvels of engineering, but the next generation promises to push the boundaries of what we can see and understand. Imagine instruments so powerful they could reveal the faintest light from the earliest moments of the universe, or detect the atmospheres of distant exoplanets in unprecedented detail. These future telescopes won't just be bigger, they'll be smarter, more precise, and equipped with technology that feels almost like science fiction. One of the most exciting developments is the rise of space-based observatories that avoid the distortions of Earth's atmosphere. Projects like the James Webb Space Telescope are just the beginning. Future designs could include telescopes with mirrors several times larger, stationed at gravitational sweet spots in space where they can capture ultra-clear images of galaxies billions of light-years away. Some concepts even propose using the sun's gravity as a natural lens, amplifying the light from distant stars and planets to levels we've never been able to study before. Then there's the potential of adaptive optics and AI-driven systems. Imagine telescopes that can adjust their mirrors in real time to counteract cosmic interference, or algorithms that sift through vast amounts of data to identify subtle patterns in the light of distant stars. These advancements could help us spot elusive phenomena like dark matter or even signs of extraterrestrial life. The future of telescopes isn't just about seeing further. It's about seeing smarter, uncovering secrets of the universe that have remained hidden until now. And with each leap in technology, we're not just observing the cosmos, we're redefining our place within it. When we think about fashion, we often picture runway shows, trendy streetwear, or timeless designs that move with the human body. But what happens when you take gravity out of the equation? Designing clothing for space presents a set of challenges that push the boundaries of traditional fashion. In zero gravity, fabrics don't drape the same way and garments don't stay in place as they would on Earth. This means space fashion isn't just about style, it's about functionality, comfort, and safety in an environment that's completely foreign to us. Imagine trying to wear your favorite pair of jeans in zero gravity. Without gravity to hold them down, they'd bunch up in awkward places, making movement uncomfortable. That's why spacesuits and clothing for astronauts are designed with precision, using materials that are lightweight, flexible, and durable. But it's not just about practicality. Space fashion is also exploring aesthetics. Designers are experimenting with textures, patterns, and colors that look and feel good in microgravity, creating garments that are as visually striking as they are functional. This innovative approach to clothing isn't just confined to space. The lessons learned in zero-gravity fashion are already influencing Earth-bound designs. For example, the use of advanced materials developed for spacesuits, like temperature-regulating fabrics or ultra-lightweight textiles, is making its way into everyday apparel. These technologies aren't just practical, they're redefining what's possible in the fashion industry. But space fashion goes beyond materials. The very concept of designing for zero gravity challenges our understanding of how clothing interacts with the body. It's a reminder that fashion isn't static, it evolves with our environment and our needs. As we venture further into space, who's to say that the next big trend won't come from the stars? The fusion of science and style in space fashion is proof that innovation knows no bounds, and it's only a matter of time before these cosmic designs inspire the way we dress here on Earth. Space exploration isn't just about rockets and distant planets, it's about us. It's about how we see ourselves, how we connect, and how we dream together. Think about the Apollo moon landing. It wasn't just a scientific achievement, it was a moment that united the world. Billions of people, regardless of nationality, race, or creed, watched in awe as humanity took its first steps on another world. That kind of shared experience has the power to inspire, to bring people together in ways few things can. Fast forward to today, and the possibilities are even more profound. As we look toward the stars, space travel could ignite a new era of global unity. Imagine international teams collaborating on missions to Mars or beyond, pooling resources, knowledge, and ambition to achieve something no single nation could accomplish alone. This isn't just about science, it's about showing what humanity can do when we work together. But the impact goes deeper. Space exploration has the unique ability to inspire generations. When kids see astronauts floating in microgravity or rovers rolling across Martian terrain, they don't just see science, they see possibility. They see a future where they can be part of something bigger than themselves. This ripple effect could lead to a surge in interest in STEM fields, driving innovation and progress in ways we can't yet fully predict. And let's not forget the cultural shift it could bring. Space travel challenges us to think beyond our immediate surroundings, to see Earth not as a collection of borders but as a single, fragile home. That perspective could foster a sense of shared responsibility for our planet, encouraging us to tackle global challenges like climate change with renewed urgency. In the end, space exploration isn't just about reaching new frontiers, it's about redefining what it means to be human. It's about pushing boundaries, not just in the cosmos, but in our hearts and minds. Whether it's through inspiring the next generation, fostering global collaboration, or shifting our perspective on Earth, the social impact of space travel could be just as transformative as the technology itself. Space travel isn't just a test of physical endurance, it's also a profound challenge for the human mind. Imagine being confined to a small, isolated environment, millions of miles away from Earth with no immediate escape. Astronauts on long missions face unique psychological hurdles that are as daunting as the technical challenges of space exploration. The isolation, the monotony, and the constant awareness of danger can take a toll on mental health. Studies have shown that prolonged exposure to these conditions can lead to feelings of loneliness, anxiety, and even depression. To counter these challenges, space agencies are investing heavily in psychological research and support systems. One approach involves carefully selecting astronauts with strong mental resilience and adaptability. But even the most resilient individuals need continuous support. That's where advancements in virtual reality come into play, offering astronauts immersive experiences that simulate Earth's environments, providing a much-needed mental escape. Additionally, real-time communication with loved ones and mental health professionals back on Earth helps alleviate feelings of isolation. Another critical strategy is fostering a sense of purpose and camaraderie among the crew. Team-building exercises, shared responsibilities, and even structured downtime are essential to maintaining morale. Interestingly, some researchers are exploring the use of AI-driven companions, sophisticated programs designed to engage in meaningful conversations and provide emotional support. These innovations are not just about surviving the journey, they're about ensuring astronauts can thrive mentally and emotionally, paving the way for humanity's deepest explorations yet. As space exploration advances, the role of governments becomes increasingly pivotal. While private companies are driving innovation, it's national and international policies that will shape the framework for humanity's journey into the cosmos. Governments have the unique ability to foster collaboration, establish regulations, and ensure that space remains a realm of peace and cooperation rather than competition and conflict. Think of it as the foundation upon which the future of space travel is built, one that balances ambition with responsibility. International collaboration has already proven its value through initiatives like the International Space Station, where countries like the United States, Russia, and Japan have worked side by side. These partnerships demonstrate that when nations unite around a shared goal, the results can be extraordinary. Moving forward, this spirit of cooperation will be essential for tackling challenges like lunar colonization, Mars exploration, and even interstellar missions. No single country can shoulder the immense technical, financial, and ethical burdens alone. Yet, collaboration requires more than goodwill. It demands clear policies and agreements. As more nations and private entities venture into space, questions about resource allocation, territorial claims, and environmental impact will arise. Governments must step in to create frameworks that ensure fair access to space resources, protect celestial environments, and prevent conflicts. For example, how should we handle mining on the Moon or Mars? Who gets to claim what, and how do we prevent a space-age gold rush from spiraling out of control? These are complex issues that require thoughtful, forward-thinking legislation. Moreover, governments play a crucial role in funding and supporting long-term space projects that may not yield immediate profits but are vital for humanity's progress. Missions to distant planets, space telescopes, and research into sustainable life support systems often require significant investment and time. These endeavors may not attract private investors, but they are essential for expanding our knowledge and capabilities in space. The future of space travel isn't just about rockets and technology, it's about the systems we create to govern our journey. By fostering collaboration, establishing fair policies, and supporting ambitious projects, governments can ensure that space exploration benefits all of humanity. This isn't just a task for scientists and engineers, it's a responsibility for leaders, policymakers, and citizens alike. After all, the stars belong to everyone. As humanity reaches further into the cosmos, a pressing question emerges: who actually owns the stars? The idea of claiming territory in space might sound like science fiction, but it's already a hot topic among lawmakers, scientists, and even private companies. Right now, the Outer Space Treaty of 1967 is the foundation of space law, declaring that no nation can own celestial bodies like the Moon or Mars. But here's the twist: it doesn't explicitly address private entities or individuals. This legal gray area opens the door for fascinating debates. What happens if a mining company extracts resources from an asteroid? Can a corporation claim ownership of materials they've harvested, even if they can't claim the land itself? Ethical dilemmas add another layer to the conversation. Should humanity treat space as a shared resource, preserving it for future generations? Or does progress demand that we stake claims and exploit its potential? Take the Moon, for example. If one country or company builds a base there, does that mean they control the surrounding area? And what about Mars, where multiple nations and private ventures are racing to establish a presence? The stakes are high and the rules are still being written. Some argue that space should follow a model similar to Antarctica, a place governed by international agreements free from territorial claims. Others believe that fostering competition through property rights could accelerate innovation and exploration. It's a delicate balance between cooperation and ambition, and the decisions we make today could shape humanity's future in space for centuries to come. As we venture beyond Earth, one thing is clear: the cosmos is humanity's final frontier, and figuring out how to share it fairly is one of the greatest challenges we'll face. Picture a classroom where textbooks are replaced by live feeds from Mars rovers, and students collaborate with astronauts on the International Space Station to solve real-world problems. This isn't science fiction, it's the potential future of education, transformed by the wonders of space exploration. As we venture further into the cosmos, the impact on learning could be profound, reshaping how we teach and inspire the next generation. Space exploration has always been a catalyst for curiosity, and in the future, it could become the backbone of STEM education. Imagine students designing experiments that are launched into orbit, analyzing data from telescopes observing distant galaxies, or even coding robots to explore lunar surfaces. These hands-on experiences wouldn't just make subjects like physics and engineering more engaging, they'd make them tangible. Instead of memorizing equations, students would see the real-world applications of their knowledge, sparking a deeper passion for science and technology. But the influence of space education wouldn't stop at STEM. The vastness of the universe has a unique way of igniting creativity and imagination. Think about it: what could inspire more awe than learning about the birth of stars, the mysteries of black holes, or the possibility of life on other planets? These topics could fuel art, literature, and philosophy, encouraging students to think beyond the confines of our planet. A child sketching alien landscapes or writing a story about interstellar travel today could become the innovator or visionary of tomorrow. Beyond inspiring individuals, space education could also foster global collaboration. Students from different countries might work together on international space projects, breaking down cultural barriers and building a sense of shared purpose. This kind of teamwork could prepare them for a world where solving global challenges like climate change or resource scarcity requires cooperation on an unprecedented scale. And let's not forget the role of virtual reality and augmented reality in this educational revolution. With VR headsets, students could explore the surface of the Moon, walk through a Martian colony, or even take a virtual tour of a spacecraft. These immersive experiences would make learning about space not just informative but unforgettable. The future of space education isn't just about teaching facts, it's about cultivating a mindset. It's about nurturing curiosity, encouraging critical thinking, and instilling a sense of wonder. By bringing the universe into the classroom, we're not just preparing students for careers in science or technology, we're inspiring them to dream bigger, to ask questions no one has thought of before, and to see the world and the cosmos in a whole new way. Art has always been a mirror to humanity's dreams and discoveries, and now the cosmos is becoming its canvas. Space art, a genre that blends science and creativity, is emerging as a powerful way to interpret the vastness of the universe and make it accessible to everyone. Artists today are not just painting stars and planets, they're collaborating with scientists, using data from telescopes and space missions to create works that are as scientifically accurate as they are visually stunning. These pieces don't just depict space, they invite us to feel its wonder, its mystery, and its scale. Imagine walking through a gallery where every stroke of the brush or pixel on the screen is rooted in real cosmic phenomena. It's art that doesn't just show us what's out there, it helps us connect with it on a deeper level. One of the most fascinating aspects of space art is how it bridges the gap between science and emotion. Take, for example, the work of artists who recreate the surface of Mars based on rover images, or visualize the swirling chaos of a black hole using equations from astrophysics. These creations aren't just artistic interpretations, they're tools for understanding. By translating complex scientific concepts into something visual and visceral, they help us grasp ideas that might otherwise feel abstract or distant. And it's not just for experts. Space art has the power to inspire curiosity in anyone, from seasoned astronomers to kids gazing at the night sky for the first time. But space art isn't just about representing what we know, it's also about imagining what could be. Artists often explore speculative ideas like futuristic space colonies, alien landscapes, or the awe-inspiring moment of first contact with extraterrestrial life. These visions aren't just flights of fancy, they're thought experiments that challenge us to think about humanity's place in the universe and what the future of space exploration might hold. In a way, space artists are like the sci-fi writers of the visual world, pushing the boundaries of what we consider possible and sparking conversations about where we're headed. What makes this genre even more exciting is its evolution alongside technology. Digital tools, virtual reality, and even artificial intelligence are giving artists new ways to bring the cosmos to life. Imagine stepping into a VR installation where you can float through a nebula or walk on the surface of an exoplanet. These immersive experiences aren't just art, they're journeys offering a glimpse of the universe that feels almost real. And as technology advances, so too will the ways we can experience and interpret space through art. Ultimately, space art does more than capture the beauty of the cosmos. It reminds us of our shared humanity in the face of something so vast and unknowable. It's a testament to our curiosity, our creativity, and our desire to explore. Whether through a painting, a sculpture, or a digital masterpiece, these works of art inspire us to look up and dream. And in a world where the mysteries of the universe are still being uncovered, that sense of wonder might just be the most important thing of all. The cosmos is vast, and exploring it comes with risks that are often too great for human astronauts. That's where robotics steps in, transforming how we navigate the unknown. Robots have already become indispensable in space exploration, venturing into environments too harsh or distant for humans to safely reach. From rovers like Curiosity and Perseverance roaming the Martian surface to probes like NASA's OSIRIS-REx collecting samples from an asteroid, these machines are our eyes, hands, and tools in the void. One of the most remarkable advantages of robotics is their ability to operate in extreme conditions. Take Jupiter's moon Europa, for instance. Beneath its icy crust lies a potential ocean that could harbor life, but the radiation levels on its surface are lethal for humans. A robotic mission could drill through the ice, analyze samples, and send back data without putting lives at risk. Similarly, on asteroids with weak gravitational fields, robots can maneuver with precision, conducting experiments and collecting materials that could unlock secrets about the origins of our solar system. Beyond exploration, robots are also poised to take on tasks that are too dangerous for human crews. Imagine setting up a base on the Moon or Mars. Robots could construct habitats, mine resources, and even repair equipment in environments where a single mistake could be catastrophic. This isn't just science fiction. NASA Robonaut and the European Space Agency's robotic arm for the International Space Station are already proving how versatile and essential these machines can be. The future of robotics in space is even more exciting. Advances in artificial intelligence could enable robots to make decisions in real time, adapting to unexpected challenges without waiting for instructions from Earth. Swarms of tiny robots might work together to map entire planets or assemble massive structures in orbit. And while robots won't replace humans entirely, they'll undoubtedly take on the most perilous missions, allowing us to explore further and safer than ever before. The stars may seem out of reach, but with robotics, we're already extending our reach into the cosmos. As we push the boundaries of space travel, the challenges of keeping astronauts healthy in extreme environments are sparking breakthroughs in medical technology that could revolutionize healthcare on Earth. Think about it, when you're millions of miles from the nearest hospital, every piece of medical equipment, every diagnostic tool, and every treatment has to be twice as effective and 10 times more portable. This urgency has led to innovations like advanced telemedicine systems, enabling doctors on Earth to guide astronauts through complex procedures in real time, even with the delay caused by the vast distances in space. One of the most exciting developments is the creation of compact, AI-powered diagnostic devices. These tools can analyze blood samples, monitor vital signs, and even predict potential health issues before they become critical. On Earth, this technology is being adapted for remote and underserved areas, bringing high-quality healthcare to places that previously lacked access. Space medicine is also shedding light on how the human body responds to prolonged exposure to zero gravity, leading to new treatments for conditions like muscle atrophy and bone density loss. These discoveries aren't just helping astronauts, they're providing valuable insights for patients dealing with similar issues on Earth, such as the elderly or those recovering from long-term immobilization. And then there's the potential for space-based research to uncover entirely new treatments. The unique environment of space allows scientists to study diseases and develop therapies in ways that simply aren't possible on Earth. For example, microgravity has been used to grow more precise crystals for drug development, accelerating the creation of medications for conditions like cancer and Parkinson's disease. What's fascinating is that these advancements aren't just about solving problems in space, they're about improving life for everyone. The innovations born from the challenges of space medicine are finding their way into hospitals, clinics, and homes, transforming how we approach health and wellness. It's a reminder that exploring the cosmos isn't just about reaching new worlds, it's about making our own world a better place. As we push the boundaries of space exploration, it's essential to pause and consider the environmental toll it takes on our own planet. The carbon footprint of rocket launches is staggering. Each mission releases tons of greenhouse gases into the atmosphere, contributing to climate change. For example, a single launch can emit as much carbon dioxide as a car driving millions of miles. This raises a critical question: how can we reconcile our ambitions to explore the cosmos with the urgent need to protect Earth? One promising solution lies in the development of greener propulsion systems. Companies are already experimenting with alternatives to traditional chemical rockets, such as electric or hybrid engines that produce fewer emissions. Another approach is the use of biofuels, which could significantly reduce the environmental impact of launches. Beyond the rockets themselves, there's also a growing focus on sustainability in satellite design. By creating satellites that are lighter, longer-lasting, and easier to recycle, we can minimize space debris and reduce the need for frequent launches. But sustainability isn't just about the technology, it's also about how we use it. Streamlining mission planning to maximize efficiency, reusing spacecraft components, and investing in cleaner manufacturing processes are all steps in the right direction. International collaboration will also play a key role. Sharing resources and knowledge can help reduce redundant efforts and ensure that sustainability becomes a global priority. The future of space exploration doesn't have to come at the expense of our planet. By embracing innovation and commitment to sustainability, we can chart a course that benefits both humanity and the environment. As we look to the stars, the ultimate goal isn't just about exploration or discovery, it's about survival and evolution. Imagine a future where humanity no longer depends solely on Earth for its existence. Becoming an interplanetary species isn't just a dream, it's a necessity. With threats like climate change, asteroid impacts, and other existential risks spreading across the solar system could be the key to ensuring our long-term survival. Think of it as a cosmic insurance policy. By establishing self-sustaining colonies on the Moon, Mars, or even beyond, we create backups for our civilization. Each new outpost would be a step toward resilience, allowing humanity to thrive even if one planet faces catastrophe. But it's not just about survival, it's also about growth. Expanding into space opens up opportunities for scientific breakthroughs, cultural evolution, and new ways of living. Consider the possibilities. On Mars, we could develop technologies that revolutionize construction, agriculture, and energy. In the asteroid belt, we could mine resources that solve Earth's material shortages. And on moons like Europa or Titan, we might find clues about the origins of life itself. Each world offers unique challenges and opportunities, pushing humanity to innovate and adapt. This vision isn't just for scientists or astronauts, it's for all of us. It's about shaping a future where humanity is no longer bound by the limits of a single planet. It's about becoming a species that thrives among the stars, carrying the best of what we are into the vast unknown. The journey will be long and challenging, but the reward is nothing less than the continuation of our story in the universe. As we set our sights on the stars, it's crucial to acknowledge the hurdles that stand between us and the future of space travel. One of the most significant barriers is technological limitations. While we've made incredible strides, developing systems that can sustain human life for extended periods in the harsh vacuum of space remains a daunting challenge. From radiation shielding to reliable life support systems, every component must be perfected to ensure safety and efficiency. And let's not forget, propulsion current methods are simply too slow for the vast distances we aim to cover. Breakthroughs in fields like ion drives or even theoretical concepts like warp engines are essential, but they're still years, if not decades, away from practical use. Funding is another massive obstacle. Space exploration is astronomically expensive, literally. Missions to the Moon, Mars, or beyond require billions of dollars, and securing that kind of investment is no small feat. Governments and private companies alike must weigh the costs against other pressing priorities, from healthcare to climate change. Even with the rise of commercial space ventures like SpaceX, the financial burden remains immense. Without sustained funding, many of these ambitious projects risk being shelved indefinitely. And then there's the issue of political will. Space exploration has historically been driven by competition, like the Cold War-era space race. But in today's fragmented geopolitical landscape, collaboration is often stymied by national interests and bureaucratic red tape. International cooperation will be key to tackling these challenges, but fostering that unity is easier said than done. It requires a shared vision and a commitment to long-term goals, something that can be hard to achieve when short-term priorities dominate the agenda. Even public perception plays a role. Space exploration is often seen as a luxury rather than a necessity, especially when so many problems here on Earth demand attention. Convincing the broader population of its value, whether for scientific discovery, technological innovation, or even planetary defense, is essential to garnering the support needed to push these initiatives forward. The road to the stars is paved with challenges, but understanding and addressing these obstacles is the first step toward overcoming them. As we wrap up this journey through 40 mind-bending predictions for the future of space travel, it's clear that the cosmos holds endless possibilities waiting to be unlocked. From lunar cities and asteroid mining to warp drives and interstellar colonization, these ideas aren't just science fiction. They're blueprints for a future where humanity stretches beyond the boundaries of Earth. Each prediction represents a leap of imagination, a testament to the power of curiosity and the relentless spirit of innovation. What ties these visions together is the belief that collaboration across nations, industries, and disciplines will be the driving force behind turning these dreams into reality. Space exploration isn't just about technology. It's about humanity coming together to solve the grandest challenges and explore the unknown. It's a reminder that the future isn't something that happens to us, it's something we create, one bold idea at a time. So, what's your take on these predictions? Which one excites you the most? Whether it's the prospect of living on Mars, traveling to distant stars, or harnessing the resources of asteroids, there's no shortage of inspiration to fuel your imagination. The future of space travel is a story we're all writing together, and your curiosity plays a vital role in shaping it. If you're as passionate about the possibilities of the cosmos as we are, don't miss out on more insights like this. Hit that subscribe button to stay updated on the latest advancements in futuristic technology and space exploration. And let's keep the conversation going. Drop a comment below sharing your favorite prediction or the one you think will change everything. The universe is waiting, and together we'll explore what's next.